Hello, everyone. I'm Frank, and welcome to Frank Puzzles. And as a request, if you like the channel, I'd appreciate it if you subscribe because it really makes me notice your support. And if you like the video, give it a thumbs up. And now on to today's puzzle. Today's puzzle is a very easy puzzle, and it's called "Like Looking in a Mirror" by Ratfakes. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each into every row, column, and box. Quads. Digits in circles are quads and must appear in the surrounding 4 cells. So basically, if this says 1, 2, 3, that means the digits 1, 2, and 3 must appear around in the 4 boxes that are surrounding it. Same thing with this in 6, 7, 8. Same thing with this in 4, 5, 6, 6, 8. So basically we know in that one, all 4 cells must contain a 4, a 5, a 6, and an 8, etc., etc. If there's only 3 of them, that means you just need know about 3 of the numbers. But you know 3 of the numbers, 3 of the 4 cells must contain a 1, 2, or 3. Actually, it could be multiple ones, but in this puzzle, there aren't. So like say there was, I don't know, around here, there was a 1, 2, 3, then you would know that there's at least 1, 1, 2, or 3 surrounding in those 4 surrounding cells, but there could be multiple ones. So there could be a 1 and a 1, and then 2, 3. That would be a possibility. So it could be like, yeah. Anyways, that's quads. Killer cages. Digits in cages cannot repeat. Cannot repeat, remember that. And must equal the value in the top left corner, top left-hand corner. So basically, these 3 add up to 11. These 3 add up to 15. These 3 cells add up to 20, etc., etc. These 4 add up to 12. And they cannot have repeat digits, so remember that. Crop key dots. Cells joined by a white crop key dot must contain consecutive values. So for example, if this was a 5, this would have to be a 4 or a 6 to maintain consecutive values. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first things first. This has a 5 in it. This also has a 5 in it. There's only one 5 possible in box 5, therefore this is the 5. In addition, we also know this is 4, 6, and 8 because they must be surrounding the quad, and this is 2, 7, 9. Therefore, this is 1 and 3 and 1 and 3 by process of elimination. This must contain a 1 because if you have 3 unique digits that add up to 8, it's either 1, 2, 5 or 1, 3, 4. So this must contain a 1, which means 1 cannot be here, which means 1 has to be here. So therefore, the 1 is over here in column 3. Same thing here. This is a 1, which means this cannot be a 1, which means this must be 1, and one of the 1s must be over here. For 12, it's either 1, 2, 3, 6 or 1, 2, 4, 5 for 4 digits. So it's 1, 1 through. So this cannot be 1, which means 1 has to be one of these two. This is 1, 2, 3, 4, 5, 6. Again, this can't be 1. Therefore, 1 is one of those two. This must contain 1. It's either 1. So it's 11, right? 11 could be either 1, 2, 8. So it would be 1, 2, and 8. 1, 3, 7. It could be 1, 4, 6, but then the problem is you also need 2 and 3 to be in around surrounding this quad. Okay, so this, yeah, okay, another thing about quads is if you have one of them, right? One of 1, 2, or 3 has to be around this quad. Therefore, it can't be in the rest of the box. So this can't be 2 or 3. This can't be 2 or 3. So if this is 1, 2, 3, 1, 2, 3, 6, the 6 would have to be here. So this cannot be 6 then, because the 6 would have to be here. Same with this, so this can't be 6. So this would be 1, 2, 8, 1, 3, 7. It cannot be 1, 4, 6, because if it's 1, 4, 6, where is the 2, 3 going to be? They would both have to be in that cell, which is impossible. So this cage must contain 2 out of 1, 2, or 3 at least. It can't contain all 3. It can't be 1, 2, or 3. So this has to be 1, 2, or 3. So it could be 1, 2, 8, 1, 3, 7, or 2, 3, 6. So this would be 2, 3, and 6. This could be 2, 3, and 6. So if this was 6, this would have to be both 2 and 3, which would eliminate 1, 2, 5, and 1, 3, 4's possibility, so there would be no possibility there. Therefore, this can't be 6. 1 of 2 or 3 is here. So 1 is here. 1 of 2 or 3 is here. 1 of 2 or 3 is here, which means the rest of the column cannot contain a 1, 2, or 3. So this is 4, 5, 6, 7, 8, and 9. This is 4, 5, 6, 7, 8, and 9. And we know 6, 7, 8 has to be surrounding the quad, so this can't be 6, 7, or 8. So this is 4, 5 next to. So if this is 4, this would have to be either. If this is 4, that eliminates 1, 3, 4 from this. So it would be 1, 2, 5. So therefore, this would have to be 5. If this is 5, that eliminates 1, 2, 5. So therefore, it would have to be 1, 3, or 4. It can never be 9. So therefore, this. If it's 9, it would have to be 8 next to it, but that's not possible. So this can't be 9. Therefore, this is a 4, 5, 4, 5 pair, which means you cannot have a 4, 5 in the rest of the column. So this cannot be 1, 6, 8. It could be 2, 6, 7. And I think it's the only possibility because it must contain 2 out of 6, 7, and 8. Yep. So it has to be 2, 6, 7. So this in that, therefore, this is the same because these are like looking in a mirror. It's exactly the same, right? Therefore, this is 2, 6, 7, which means this can't be 6 or 7. So this has to be 2 and 8, 2, 3, and 8, and therefore this is 1. This has to be 3, which makes this 1, 4, 5. Sorry, 1, 3, 4. Which makes this a 4, which makes this a 5. This can't be 4. So this can't be 6 or 7 or 8, so this must be 9. This is exactly the same setup. So all the logic we used is valid there. This can't be 3 anymore. So this has to be 4. This is 5. This is 1 and 3. Which means that can't be 3 or 4. This can't be 3 or 4. This has to be 2 and 8, which forces this to be the 2 and this to be 8. So that's 1. This is 2, 6, 7. So therefore, this is 8, and this is 2. This has to be 9. Now, the only difference is this has to be 14, and this has to be 20. So this is 14 without a 1 or 2. So it could be 3, 4, 7, or 3, 5, 6. So either way, it contains a 3. So this can never be 3. This can't be 5. This can't be 5. So this is 4 or 6 in with 1, 2, 4, or 6. Same with here. This can't be 5. This can't be 5. If this is, yeah, if this is 1, 2, 4, 5, the 4 has to be here and the 5 has to be here. So this can never be 4. This is 3, 5, 3, 4, 7, or 3, 5, 6. So 3, 4, 7, or 3, 5, 6. So this is 6 or 7. This is a 6 or 7, which means 6 or 7 cannot be in the rest of the row. This is consecutive with this. 3, 4, 7. It would have to be 5 with the 4. If it's 3, 5, 6, the 3 and the 5 and the 6 all work. So it could be the 3 and the 5 would be with next to the 4. This 5 cannot be next to the 6 because the 6 would be here. And that 6 or 7 cannot be here. So this has to be 9 because there's no other place for it. 3, 5, 6. The 6 cannot be next to a 7 because it's there, and it cannot be next to a 5. So this can never be 6. Now this is 20. It cannot be 3, 8, 9. It could be 4, 7, 9 or 5, 6, 9. So either way, the 9 has to be here, which means the 9 can never be there, though. So 4, 7, 9 or 5, 6, 9, which means, and that's a 6 or a 7. So this cannot contain a 6 or 7. It could be 3, 4, 5 because the 9 we know is here. So this could be 3, 4, 5. So this can't be 6 or 7. This is 4, 5 with 3, 4, 5. So 4, 5 cannot be here. It must be one of 6 or 7. This can't be 1 anymore because this is a 1. This has to be 3. Therefore, 3 cannot be here or here. This can't be 4. So this is a 6, 8 pair, which forces the 4 to be here. These are consecutive, so cannot contain a 2. It cannot be 1, 2, 3, 4, 5. So it could be 6, 7, oops. 6, 7, 7, 8, or 8, 9. So 2 is one of these two. This can't be 4 for the same reasoning that we had here, because if it's 1, 2, 4, 5, the 4 would have to be here and the 5 would have to be here. This can't be 3, so this is 4, 5, this is 4, 5, which makes this a 3. Because 3 can never be here as 3, 8, 9. This has to be a 1, 3 pair, but 3 can't be here. Therefore, this is a 3. This is a 1. We have 1, 4, 8, and 9. Obviously, 1. Okay, so this has to be 8. And this has to be 8. These can't be 8. This can't be 1. This has to be a 4. So this can't be 4, so therefore this is 6, 3, 1, and 2. This can't be 3, so this is a 1. So there's no 1 here. This can't be 1, therefore this is a 3. That's a 1. This is a 3. This is a 1 by Sudoku. These are consecutive, so it must be 6, 7, or 8, 9, because 2 cannot be here anyways. So whereas a 2 in row 5, it has to be here. So this is a 7, 9 pair. This can't be 3, so it's 4, 5, or 4, 5 here, which means these can't be 4, 5. This can't be 4 because of that 4 there. Therefore, by Sudoku, this has to be a 5, which forces this to be 4. And this is 5, 6, and 9, which forces this to be 7 and this to be 6. This 4 forces this to be 6, which makes this a 3 and this a 2. So this can't be 2 anymore. These can't be 9, so therefore this is 4, and that 4, that becomes a 1, and that's a 9. So this can't be 6 or 9, so this is 7 or 8. The 7 or 8 has to be with a 6 or a 9, because otherwise the other side doesn't work. So therefore this is 6 or 9 there. This can't be 4 or 5, so this must be 4 or 5. So therefore this is a 7. This must be 7, 8 then, which can't be 7, so therefore this is 8, which makes that a 7, which makes that 6. So therefore this is 8 and 9, so that's 8, that's 9. The 2 cannot be here in box 2. The 2 cannot be here. Therefore, this must be a 2. We're looking for 7 and 8. This can't be 8, so this is 7. This has to be 8 in row 3. This must be a 5 by Sudoku, and this must be a 7 by Sudoku. We have a 5 and 6 missing in column 8, so therefore this must be a 5 because the 6 can't be there. This must be a 6, which forces this to be a 5 and that to be a 9 by Sudoku. Let's see. This is 2 and 8. We're missing in row 7, so therefore this is a 2. This is an 8, which forces this to be 6, which forces this to be 8. So this can no longer be 6, so this is 9. That's 6. This is 7. This is 9. All of this by Sudoku. This can't be 6 or 7, so this must be 3. This can't be 3. What are we missing? This is 1, 4, or 7 that we're missing. Where's the 1 in column? Yeah, in row 2, it has to be here because of these ones. This can't be 1 or 4, so this is 7, which makes this a 4. This can't be 7 anymore, so this must be 6, which adds up with 5 to make 14. So therefore, this is a 4. This is a 5. This can't be 6, so this is 7. This is a 6. And now we're just doing Sudoku. This is a 9. This is a 4. And this is a 7. And that's a solution. Fairly straightforward. It is like looking in a mirror because most of the things were the same, right? On one corner, there was one side. You had the exact same thing on the other side. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.